Okay, so third video on surds. Find the value of the following and state whether your answer is rational or irrational. Now, when you've got a bracket here squared, you just got to use FOIL, right? FOIL can be used with surds just as it is used with algebra. We just need to be careful and just use what we've learnt. It's important you've watched surds 1 and surds 2. Now, in this case here, FOIL. Okay, so remember FOIL. Firsts, outers, inners, lasts. The first here would be that, first in each bracket. 3 times 3 is 9. Then you've got the outers, the ones on the outside. So that one's on the outside, that one's on the outside. So 3 times root 5. Well, 3 times root 5, we just write as 3 root 5. Okay, you don't need to put times in between them. That's how you write it. Then you do the the inners, the ones on the inside. Root 5 times 3 is 3 root 5. Okay, so we write the 3 first, then the root 5. And then the lasts, now remember the lasts, root 5 times root 5. Remember, when you times the root by itself, you just get the number inside. So you get that. Then when we simplify this, look at the numbers here. I've got 9 and 5. So add them, which is 14. 3 root 5 and 3 root 5 is a 6 root 5. Okay, so the root 5 stays the same, but you got 3 and 3, make 6 of them. And your answer is here. Now this bit here is like a whole number, but this here is an irrational number. So when you put it all together, it's still an irrational number. Okay, this is irrational, plus 14, still going to be irrational. If you did this in your calculator, it would be a horrible number. So you'd write that down, irrational. Okay, question 2, or part B. Again, you rewrite this out twice. Okay, so you've got to do FOIL again. So firsts, now in this case here, firsts, root 12 times root 12, we'll just think about it, that would be root 144, but it's just 12, isn't it? Root times itself is 12. Outers, root 12 times root 3. Okay, so when you times a root, you can put them together, so root 12 times root 3 is the same as 12 times 3 is 36, so root 36. Inners then, root 3 times root 12 is the same as root 3 times 12, which is root 36. And then the last, root 3 times root 3 is just 3. Okay, so you get that. But what's interesting here, of course, is that root 36 is just 6. Okay, so you get your answer then, add them up, and you get, I think that's 27, isn't it? And your answer then is rational, because it's a nice number, and it doesn't go on forever. This one here then, part C, now in a way this isn't a double bracket because we've got single brackets here and we just need to simplify. Okay, but we do multiply through each term here. So root 3 times 5 is 5 root 3. Okay, root 3 then times root 3 is just 3. And in the second bracket, root 3 times 5 is 5 root 3, but it's a minus, isn't it? So minus 5 root 3. And let's be careful here with this term here. The end, well, you've got a 2, haven't you, in terms of numbers in front, but also it's minus times a minus, isn't it? Minus root 3 times minus this, so minus times a minus is a plus, but you've got a 2 in front, and then you've got root 3 times root 3, which is just 3. Okay, so a bit more work to do here. So 5 root 3 then, and minus 5 root 3, well, that becomes 0. You've got a 3 there, and add then 2 times 3, which is 6. So add them together, you get 9, and that is rational. So last one then on here, again write them out twice. So first, root 20 times root 20, there's no need to work that out, you just know it's going to be 20. Okay, if you did work it out, you get root 400, which is 20. Then root 20 times root 5, well that would be root 5 times 20 is 100. Inners then, same, 5 times 20 is 100. Lasts then, root 5 times root 5 is just 5, but because it's minus times a minus, you get plus. And what's interesting then, of course, root 100 is 10, root 100 is 10, and you get an answer which is rational. Okay, and we're done.